Welcome to the High Performance Liquid Chromatography of Proteins experiment. In this simulation, we will go through a series of steps to separate and detect amino acids in a tissue sample. The following tasks will be performed. Prepare the mobile phase using vacuum filtration. Prepare protein samples by acid hydrolysis prior to injection. Perform online OPA-FMOC sample derivation and injection. Set the parameters for an HPLC run. Visualize the HPLC results on a chromatogram. General steps for amino acid analysis. Prepare HPLC mobile phases. Prepare amino acid standards. Prepare an internal standard, IS, stock solution. Tissue sample preparation. Perform online derivation. Set detection parameters. Let's begin the experiment. At the top of the page, you'll see a progress bar indicating how far you've progressed. In the upper right corner, there's a Stages button that shows all the experiment stages and allows you to navigate to any stage. Now let's start by preparing HPLC mobile phases A and B. Note, mobile phase A is consumed more quickly than mobile phase B. Therefore, we recommend preparing 2 liters of mobile phase A for every 1 liter of mobile phase B. Preparation of 1 liter of mobile phase A. 1. Solvent preparation and pH adjustment. Step 1. Weigh 1.4 grams of anhydrous sodium hydrogen phosphate by doing the following. A. Place a piece of paper on the scale. B. Tear the scale to 0. C. Add sodium hydrogen phosphate with a spoon until the weight reads 1.4 grams. D. Add the sodium hydrogen phosphate to a 1 liter flask. Step 2. Weigh 3.8 grams of sodium tetraborate. A. Place a piece of paper on the scale. B. Tear the scale to 0. C. Add sodium tetraborate with a spoon until the weight reads 3.8 grams. D. Add the sodium tetraborate to the flask. Step 3. Fill the flask to the 1 liter mark with HPLC grade water. Step 4. Slowly add 1.2 milliliters of concentrated hydrochloric acid to the flask, adjusting the pH to approximately 8.4. Step 5. Stir the solution with a glass rod to ensure complete dissolution of borate crystals. Step 6. Add small drops of hydrochloric acid as needed to adjust the pH to 8.2. pH is measured by a pH meter. Mobile phase B is prepared from acetonitrile, methanol, and water in the following ratio: 45 parts acetonitrile, 45 parts methanol, and 10 parts water by volume. 2. Mobile phase A filtration using a vacuum. Step 7. Connect the flask to the adapter glass, which is then connected to the vacuum tubing. Step 8. Place the membrane at the center of the adapter glass using forceps. Step 9. Add drops of mobile phase A onto the membrane filter using a dropper. Step 10. Place the funnel cup on top of the adapter glass. Step 11. Clamp the funnel cup in place. Step 12. Connect the vacuum tubing to the filtration apparatus and turn on the vacuum. Step 13. Rinse the apparatus with mobile phase A using a dropper. Make sure that the mobile phase covers the interior surfaces of the cup. Step 14. Disconnect the vacuum tubing and turn off the vacuum. Step 15. Rinse the flask with filtered mobile phase, pouring it into a waste container. Ensure the interior of the flask is well rinsed. Repeat this process 2 more times with mobile phase A. Step 16. Reconnect the upper part of the filtration apparatus. Step 17. Connect the vacuum tubing and turn the vacuum back on. Step 18. Add the mobile phase A to the filtration apparatus and allow it to filter. When done, disconnect the vacuum and remove the upper part of the apparatus. Step 19. Rinse the mobile phase A bottle with some filtered mobile phase A and shake the bottle. Step 20. Discard the rinsing solution. Repeat the rinsing of the mobile phase A bottle twice. Step 21. Pour the filtered mobile phase A into its bottle. To prepare injection diluent, add 0.4 milliliters of concentrated H3PO4 to 100 milliliters of mobile phase A in a 100 milliliter bottle. Store at 4 degrees Celsius. Stage 2. Prepare amino acid standards. Extended amino acid standard. Internal standard stock solutions. Step 22. Partially fill a 500 milliliter volumetric flask with HPLC grade water. Step 23. Add 4.2 milliliters of concentrated hydrochloric acid to the flask to create a final concentration of 36%. Mix thoroughly using a pipette. Step 24. Fill the flask to the 500 milliliter mark with water. Store at 4 degrees Celsius. Step 25. To prepare the extended amino acid stock solution, follow these steps. Add 59.45 milligrams of asparagine to a 25 milliliter volumetric flask. Step 26. Add 59 milligrams of hydroxyproline to a 25 milliliter volumetric flask. Step 27. Add 65.77 milligrams of glutamine to a 25 milliliter volumetric flask. Step 28. Add 91.95 milligrams of tryptophan to a 25 milliliter volumetric flask. Step 29. Fill the flask halfway with 0.1 normal hydrochloric acid. Shake until dissolved. Step 30. Fill the flask with water to the 25 milliliter mark. The total concentration is now 18 nanomoles per microliter for each amino acid. Step 31. Transfer 5 milliliters of the stock solution to a new flask. Step 32. Dilute with 45 milliliters of water to reach a final concentration of 1.8 nanomoles per microliter for each amino acid. Note: store these solutions frozen as they are unstable at room temperature. Discard upon any sign of reduced intensity. Stage 3. Prepare internal standard stock solution. 1. Primary amino acid internal standard stock solutions. Step 33. Weigh 58.58 milligrams of norvaline and place it into a 50 milliliter volumetric flask. Step 34. Fill the flask halfway with 0.1 normal hydrochloric acid. Shake until dissolved. Step 35. Finally, fill the flask to the 50 milliliter mark with water. The final concentration is 10 nanomoles per microliter for each amino acid, standard sensitivity. 2. High sensitivity internal standard stock solution. Step 36. Transfer 5 milliliters of the primary stock solution to a 50 milliliter volumetric flask. Step 37. Dilute with 45 milliliters of water. The final concentration is now 1 nanomole per microliter for each amino acid. Store at 4 degrees Celsius. Note: calibration curves can be created using 2 to 5 standards based on experimental need. Stage 4. Tissue sample preparation and hydrolysis. Step 38. Add 500 milligrams of minced tissue sample to an Eppendorf tube. Step 39. Add 5 milliliters of 0.2 molar perchloric acid to the tissue in the Eppendorf. Step 40. Centrifuge the Eppendorf at 15,000 revolutions per minute and 4 degrees Celsius for 10 minutes. Ensure balance in the centrifuge by placing a tube with an equal volume of water opposite to the sample. Step 41. Pipette the supernatant into a second Eppendorf. Freeze and dry the supernatant in a lyophilizer. Hydrolysis of protein samples. Step 42. Dilute the dried protein with 200 microliters of 6 molar hydrochloric acid. Step 43. Add 5 microliters of the internal standard to the Eppendorf. Mix thoroughly using a pipette. Step 44. Transfer the solution into a hydrolysis tube. Step 45. Connect the tube to a nitrogen bottle. Step 46. Purge the tube with nitrogen until the fluids evaporate. Turn on the nitrogen valve, then turn it off when the fluids evaporate. Step 47. Connect the tube to a vacuum pump. Run the vacuum for 10 minutes. Repeat the nitrogen purge and vacuum steps 2 more times. Seal the tube under vacuum. Step 48. Heat the tube to 110 degrees Celsius in an oven for 24 hours. After cooling, the contents are transferred to a test tube. The test tube is put in a water bath at 60 degrees Celsius to be dried with the help of a gentle steam of nitrogen. Step 49. Dissolve the pellet in 200 microliters of high-purity water. Stage 5. Sample derivatization and device parameter setting. Step 50. In the ChemStation software, set the sample derivatization and adjust the necessary parameters for running the device. The experiment has been completed.